morning, everybody. Welcome to the second day of our Craft/Blue Sky conference. And I hope you liked yesterday. And I hope you liked also the cultural artistic program that we had. The relevance of it, I mean, much of it was in Hungarian. Sorry for those who didn't manage to follow, but some of the relevance of it was that there was a section from the trilogy written by Agatha Christoph, who was sort of a local writer. She was from a nearby village, and she ended up in Switzerland, and she wrote in French. So she's a kind of a Hungarian-born Francophone female writer, and the Institute took it on to kind of rehabilitate her and to emphasize the importance of her works, also for the Hungarian literary canon, as well as for the international. So some of it was related to her oeuvre, and that's why the artists put this show on. So just for you to kind of contextualize it a bit. And today, if you saw the program, we have a jam-packed program also for the morning as well as for the afternoon. And as a bit of housekeeping, we don't have a coffee break in the morning indicated in the program. However, if you would like 5 minutes, I will scan you and see when the attention is kind of wilting a little bit. Or if you should need coffee at any point, please feel free. It's put out, so you can go and have some if you need it. But we will start the program and we will go until noon, and that's when we will have lunch. So, and I would like to ask our first presenter. This morning is all on future risks. So that's the topic this morning, and all of the talks will be asked to reflect on this theme. And I would like to ask Petra to come to and take the microphone from me. Petra Malisan, we've already been in touch, and we've already been partaking in their Catalyst series run by Udine University. And Petra is a researcher in environmental sciences and energy engineering, and they run a very successful UNESCO chair in safety and disaster risk reduction. Yes, and they have a wonderful platform that they have developed. So, Petra, the floor is yours.
Thank you so much. Okay, thank you so much. First of all, I want to thank you for inviting our chair to this meeting. This is the third year, and we established this relation in 2022 with you, asking you to participate to our platform, and we are grateful for coming here to this intersectoral, interdisciplinary conference. So for us, it's very important to put all these initiatives together. So I'm bringing the greetings from the UNESCO chairholder, Professor Grimas, who was here last year, but this year cannot because of institutional commitments. One thing before starting my presentation is the name of the UNESCO chair I belong to, that is Intersectoral Safety for Disaster Risk Reduction and Resilience. Why I'm stressing this? Because the entire presentation I will give is related to the concept of intersectoral safety. Because safety, we see safety as a target that we must continue pursuing, but we cannot achieve safety without having intersectoral, interdisciplinary, interstakeholder, intergenerational dialogues. So the dialogues are and the cooperation, as well as responsibility and also creativity, are the key words for reaching safety. So that's important, and that's why we see that our chair works very well with your activities, iASK activities, and your UNESCO chair, because we have this common goal of reaching these approaches, of adopting these approaches. We apply intersectoral safety to the concept of disaster risk reduction. Sorry, let me move on. Wait, wrong size. Okay, because we all know, and we saw also together yesterday during the presentation of yesterday, that events and phenomena have a strong impact on the territory. Climate change, natural hazard, human activities affect more and more our world with greater intensity, greater frequency, and this creates social and natural systems be more and more affected, as well as they are more and more interconnected, and our world is more complex. So we all recognize that this is the situation of our world today, and we cannot approach this situation without a systemic approach. We must consider everything together, and this means that we must strengthen the cooperation among countries, among disciplines, among stakeholders, and we must adopt an intersectoral approach to improve both safety and resilience. And to address these challenges, we all know that UN agencies developed the Sustainable Development Goals, so the goals that we aim to reach in the next period. And in order to address disaster risk reduction, there is the Sendai framework for disaster risk reduction, a global framework to address these challenges. What they say, that our world is at risk, we know all this, but in order to face this problem, we need to change our way to approach our world. We cannot work by silos, but we must work all together, interconnected, and we must transform the governance approaches. So a new course is needed, and this new course must work through systemic approaches, working with uncertainty, with complexity. So we must pass, as we always hear during UN meetings, we must pass to action. So in our world, we don't only need to understand the world, but we need to understand the world in order to pass to action and achieve a more resilient future. But we cannot do this by working by silos, by working in our simple and unique context, but we must work all together. For doing this, we developed in 2022, with the support of the Central European Initiative, the ResilieEnhance program, a program aimed at enhancing the resilience to disaster for sustainable development. And this program foresees the implementation of a series of activities with the aim to link diverse viewpoints, diverse expertise, and the knowledge of experts in different disciplines, so interdisciplinary approach to contribute to resilience. We developed, and we are continuously developing through in-person meetings, online meetings, the elaboration of recommendation and reference guidelines to address the issue of territorial resilience to disasters. We created an interdisciplinary network with experts from scientific institutions. iASK is one of these, and the UNESCO chair is one of these. UN agencies, European institutions, regional and national, governmental and local territorial institutions all together to promote an holistic approach for increasing territorial resilience to disaster. As well as we want to increase the synergies between scientists and policy and decision maker. Yesterday I took some notes from each of your presentations and the keywords that arose was building bridges. So what we are doing is building bridges between scientists and the policy and decision makers, as well as among other stakeholders. So the ResilieEnhance program is developed at different levels. The main level is the one of the ResilieEnhance Platform in the Central European area that put together the experts I already mentioned for this common goal. But we also recognize the importance of working locally with local communities. So we are developing actually a cycle of short conferences in Italian language. These are in person, very simple conferences. The icon is the small coffee, so like the espresso coffee in a drop. RES stands for Experiences of Resilience. And we have these short conferences with local persons speaking about experiences of resilience in our territory from different viewpoints. And then we have locally with the high school students this Eureka, so the idea Eureka project that is related to young high school students that brings together young students with older generations to foster an intergenerational knowledge arena. So we want to build bridges not only among stakeholders, scientists, but also between new generation and older generation, because without this strong interconnection, strong cooperation, we cannot go further in our future for building future resilience. And this is a local level. At global level, we are developing a worldwide approach that is the resilience catalyst. We recognize, as being UNESCO chair, that there are almost 1,000 UNESCO chairs all around the world working with centers of excellence with the related topics. So we decided to put together UNESCO chairs working with disaster risk reduction and resilience. We selected 20 of them in order to put together their expertise and foster dialogue among these UNESCO chairs. We call this approach resilience catalyst because we see that research, UNESCO chair, and this dialogue is a catalyst to promote resilience for the future. What we did is that last year we launched this dialogue series called Resilience Catalyst to leverage the expertise of the UNESCO chairs. We first developed a global webinar that the name was The Interplay of Education, Science and Culture, so the three main pillars of UNESCO, that work together for transforming governance, for building resilience to disasters. So that was the topic we discussed with all the UNESCO chairs that were participating. And after this, we launched the talk series, so a series of webinars and dialogues between UNESCO chairs in order to share the different expertise within this network and in order to foster and identify these potential areas for collaborations. So we leverage intersectoriality, another keyword we listened yesterday a lot, and we foster real-life discussion groups among these UNESCO chairs. These are the UNESCO chairs participating to these meetings that were selected from the list of UNESCO chairs, considering those having the words resilience, disaster and risk in the title, but this was only the first initial beginning, so we want to enlarge this network, so we started with few chairs in order to start. I mean, there are, at the end, we started with 20, but only 14 were participating. And, but we want to have these 5 minutes, very short dialogues in order to understand what are we doing, how can we connect each other, how can we work together for future resilience. So what we did in this first global webinar, the idea was to have this short presentation meeting to outline the perspective and the initiatives of the chairs, of each chair, in order to understand how they leverage their contribution to disaster risk reduction and resilience. For example, we discussed the role of education in cultivating collaborative, transformative leadership for resilience. We discussed how traditional and local knowledge can inform risk governance through inclusive partnership. We discussed about good practices of science policy practice interface, so go to action, for co-designing solutions. And we designed how to leverage culture for strengthening social cohesion and community-led resilience action. So these are also the keywords of, okay, thank you so much. Oh. Okay, so we presented case studies to demonstrate, they presented case studies to demonstrate how they work together. We ask also to each chair to map their contribution into UNESCO strategic objectives. Through this characterization chart, we have the intersectoral chart where we ask to position each chair in the education, natural science, social and human science, culture, communication and information, ocean science aspects of UNESCO, as well as, for those of you who don't know, UNESCO has a medium-term strategy until 2030, 2029, where they have 4 main objectives and corresponding outcomes. And we ask to each chair to position themselves within these aspects through these charts. And we collected the charts for each chair, and these are presented in the report that you can find in our website. And what came from this is that, as you can see from these graphs, there is main contribution in education and natural sciences, but there is evident intersectoriality approaches by all the chairs that were involved. So in order to work for resilience and disaster risk reduction, it is not possible to have one single sector, one single discipline, but intersectoriality is an important aspect of this, essential. We continued after this meeting with the idea of building a long-lasting community, and we developed the Resilience Catalyst talk. So this talk serves as a platform for exchange where each chair describes its activities more in depth and promote the exchange of ideas and foster intersectoral collaborations, because all the chairs are participating to these meetings. So we promoted this active think tank among chairs. And we developed a specific web page where you can go and look all these meetings we had together. And just to show you very briefly, until now we have 7 meetings, what we're thinking is about multi-hazard risk and resilience of educational infrastructure, interdisciplinary higher education for sustainable development for creating resilient societies, enhancing resilience of water structure, high-performance multi-hazard modeling for disaster risk reduction. So we put together different disciplines, different concepts. We go on, urban resilience. Your chair presented the activities of cultural heritage management and sustainability of your chair, the risk assessment and early warning for community resilience. So we put together all these different approaches in order to get a unified and collaborative platform for looking forward future risks. So just to conclude, the key takeaways I want to highlight from these activities is the importance of facilitating knowledge exchanges. So what we want is to develop this platform for exchanges with these recorded talks to assure that we reach a wider audience, that we build bridges among participants. We want to leverage expertise for resilience, so with the initiative, leverage the different expertise of the UNESCO chairs, and this aims to strengthen disaster risk governance and to build resilience. We want to promote knowledge bridge between science, decision makers, and practitioners, as well among new generations. We want to embrace an integrated approach, so we developed an interdisciplinary network. And also to come to the words of Professor Mislevis yesterday, we need a common lens. You say that we need a common approach for big problems. And what we build is we start to build this common lens, especially in the ResilieEnhance platform, to face the very big issue, the very big problem, challenge of having a very complex world, interconnected and vulnerable. So new governance approaches are necessary. We must talk all together, but in order to talk all together from different disciplines, we must use a common lens, a common simple lens that permits us to talk together and to put together our solutions for facing new risks. Thank you.
Thank you, Petra. If you have any questions or comments, please save them, because we will have a Q&A session at the end of this block. We only have time for clarifying questions in between talks. Okay, next up we have Feríz Rádi. That's you. Welcome. Welcome. He's the young breeder of the year, and he will talk to us about precision breeding. Yes, he's a young PhD. He earned his doctorate at the University of Szeged in the Biological Research Center, and very quickly he is now also in the Rector's Advisory Board of the University of Agriculture and Life Sciences, and he is also the chairman of the Society of Plant Breeders. So very exciting, very interesting person you are, and the topic you brought today, I think it might seem as a one bit one little topic. However, I think it will very neatly fit into our larger issues. And the floor is yours.
Thank you very much for the introduction. First of all, let me express my gratitude to the organizers for the invitation. And let's start this presentation, please. So I don't think that I should introduce Festerich Imre for anybody in this room. But firstly, for the beginning, we should talk about his life just for a little bit. Imre Festerich was born in 1764 into the famous Festerich family, of course. As a young man, he studied in Vienna and then entered the military. Around 1780, he served as a military officer in Kőszeg, where he learned about military and the importance of organization. After his discharge, he started farming, and his interest increasingly turned to breeding, especially sheep farming. His goal was to widely disseminate modern knowledge and thereby boost Hungarian agriculture. The impact of his work on genetics, that he corresponded with famous farmers of the time and came into contact with the Sheep Society, which was founded in Brünn to develop sheep breeding. Festerich conducted practical experiments in the field of sheep farming and shared his observation with the members of the society. His important realization was that the rules of heredity influence the results of animal breeding. This became the basis of the Festerich laws, and his work 40 years later served as the basis for the research of George Mendel, who is known in history as the father of heredity. So that's about his life. 200 years after Festerich, work genetics and biotechnology has become one of the fastest growing scientific fields in the world. Here are some Nobel Prizes, for example, from the past, but believe me, these are not the last ones. Emmanuel Carpentier and Jennifer Doudna, 2020, development of the CRISPR-Cas9 genome editing technology. Mario Capecci, Martin Evans, and Oliver Smithy's development of gene targeting in mice, creation of knockout mice. And the last one, this is my favorite, Barbara McClintock, 1983, discovery of mobile genetic elements called transposon. And this is my favorite because it was found in corn, of course. What is precision breeding? Precision breeding is a quite wide range of scientific areas, but we have to talk about molecular breeding. Molecular breeding is modification of the plant genome and detection of its modification using laboratory techniques. We have GMO, of course, but in this section we are not going to talk about that. And we are going to talk about that, genome editing, what is the most modern trend in biotechnology now. Here we have a video what is summarize what is genome editing indeed.
CRISPR gene editing works by using a specialized protein called Cas9, guided by RNA, to target and cut specific DNA sequences in a cell. This allows scientists to precisely edit genes by adding, removing, or altering genetic material. CRISPR acts like molecular scissors, enabling the correction of genetic defects, the enhancement of certain traits, or the study of gene functions. Its precision and efficiency make CRISPR a groundbreaking tool in medicine, agriculture, and research, with the potential to cure genetic diseases, create disease-resistant crops, and even engineer organisms in ways previously unimaginable.
Thank you very much. Okay, thank you. So let's imagine together how does it work. Every living cell contains a nucleus. Imagine the nucleus as a coiled ball of yarn on which beads of 4 different colors are strung. For interest, in humans there are 3.2 billions of beads, and in maize there are 2.3 billions of beads. The sequence of the beads is unique and it determines the traits of the organism. Genes are built from these beads, and one gene consists of a minimum 100 to up to 1 million beads. And by changing, this is the most important part, by changing even a single nucleotide, what is with the bead, a significant biological effect can be achieved. We should talk about old school breeding. There are no problem with the old school breeding, and this is a safe and quite old method, but maize has nearly reached the upper limit of its genetic yield potential. Yield averages can no longer be increased dynamically. The focus must be on yield stability. And here we have new genomic techniques, and these techniques are suitable for guarantee future development in agriculture in a safe and sustainable way. For example, targeted effects, general stress tolerance, increase in kernel size and yield average, and improvement of nutritional values. There are some examples from the field. For example, Waxy maize, in the grain yield of Waxy hybrids, only amylopectin type starch is produced, which increases feed digestibility and provides an excellent raw material for starch production. The most important in the global warming, drought-tolerant maize. The use of drought-tolerant hybrids can significantly reduce loss of yield average caused by the weather and can be increased up to 30%. And the last one, resistant fruits and vegetables. When cultivating plants resistant to viruses and other pathogens, no chemicals are needed during production. This reduces the biological footprint and lowers the risk of chemical residue accumulation. And here we have some different legal regulation around the world, and it's very important for the rest of the presentation. You can see that in the USA, the GMO is approved. NGT1, what is precision breeding, is not different from regular breeding. And NGT2 is GMO, of course, and it's under the GMO legislation. In China, not absolutely the same, but almost the same situation. And in the European Union, GMO is denied, NGT1 not regulated yet, which is the biggest problem, and NGT2 is denied because it's GMO, of course. The European Union legislation is much slower, more bureaucratic, and often represents competitive barrier to its own global competitiveness. What is the difference between America and Europe? Difference between product-based and process-based authorization. It's very important. In the United States, regulations are determined by the final product rather than the process. If it does not differ from an already approved organism, it is generally authorized regardless of the production method. In Europe, the primary focus is on the process rather than the final product, even if the production technology results an essentially recognized organism. And here you can see that the world is led by the USA and China in this technology, and they are leading the world with the application of these researches, and the European Union is going to fall behind, and its result brain drain effect in the scientific life. And now we are going to translate the European bureaucracy to the level of biotechnology.
That's a good job.
Yeah, let's try it. So here are some really serious diseases. For example, first of all, SMA is a spinal muscular atrophy. It's a rare genetic disorder caused by mutations in the SMN1 gene, leading to insufficient SMN protein. This deficiency results in progressive degeneration of motor neurons, causing muscle weakness and atrophy. In young ages, this illness is deadly, and you often see this in the late night news when we are collecting donations to children because the therapy is cost $2 million. And this illness can be legally and routinely cured with the same gene therapy tools what we not regulated yet in the agriculture. Secondly, retinal dystrophy. Retinal dystrophy is a group of inherited eye disorders that damage the retina, the light-sensitive tissue, and back to the eye. It often leads to problems with vision, such as night blindness, loss of peripheral sight, or gradual loss of central vision. And if you are going to the Semmelweis University Ophthalmic Gene Therapy Treatment Center in Hungary, this illness can be legally and routinely cured with the same gene therapy tools. And the last one, sickle cell anemia is a genetic blood disorder in which red blood cells take on a rigid crescent or sickle shape instead of being round and flexible. These mishapen cells break down more quickly and can episodes an organ damage. The condition is inherited when somebody receives 2 sickle cell genes, one from each parent. And finally, this illness can be legally and routinely cured with same gene therapy tools what we not regulated yet in agriculture. And the question is immediately here among us, how is it possible? And of course, I'm not gonna answer this question, but you can thinking about that. Finally, we must find a consensus. The goals of biotechnologists and environmentalists are aligned. The world's population is growing. Demand for food is increasing. Demand for energy is increasing. We must find solutions together. There is a need for new technologies that ensure innovation, competitiveness, and sustainable development for European agriculture. At the same time, there is both professional and societal demand for create the consensus regarding new breeding techniques. We should care about the future. Environmental protection, sustainable and safe development are always the first consideration if we agreed we borrowed the earth from our grandchildren. European biotechnologists of my generation do not want to conquer China or the USA, of course, but they have the legitimate claim to be at the starting line in a global, scientific, and industrial competition. I sincerely hope that the European Union legislation will soon make this possible. Thank you very much for your attention.
I would like to ask our former fellow, Dr. Elira Luli, to have the mic here. She's a researcher and a lecturer at Luarasi University and also Tirana State University in Albania. And we used to sit in the next house over with each other. And she's also had a major role in the prospective UNU institute that it can be founded here. So the floor is yours.
Yes. I think it's working. This one?
Yeah. It should.
Well, it's such a great pleasure to be here, and I want to congratulate you for organizing these amazing academic events like this conference, and I'm glad to be part of that. And I'm also glad to enjoy my 20 minutes, because usually we have to stick to this 10 minutes time frame, very strict, which is the same time that we use in the Balkans to order the coffee, for example, and then continuously chat about politics and everything and disagree on nothing. So we could at least agree on some issues here that are really important and affecting humanity and societies all around the world. My presentation today is about the dynamics of youth immigration and in the Western Balkans and future consequences, present and future consequences. And I try to see this through a comparative analysis, but through a human security lens, through a human security perspective. We know that youth immigration is becoming a very challenging and complex issue in our region due to massive immigration or due to massive departure of young professionals and students. And according to the United Nations Department on Social and Economic Affairs and International Migration Stock, this is not a normal issue that our societies are facing, but this is a massive migration going toward the trend of depopulation and brain drain, because only in 2020, around 5 million of people have left the region, their countries. That means 1 in 5 citizens have already left. But this is very concerning if we consider the small population of our region, about 17 million of people, and that means roughly 21-25% of the people have already left since in the 90s. And that's because of issues related to lack of employment, lack of opportunities, poverty, and weak conditions in some fundamental vital sectors. And what is more concerning, for example, is when you hear the responsible people at the governmental level talk about this issue, they tend to simplify it and they tend to justify it as a trend or phenomena we have been witnessing for a long time also within the European Union in the frames of labor market policies, circular migration, or free movement of people. But that's not the situation in the Western Balkans, because I'm convinced that this is really connected with lack of guaranteed human security, which is actually encompassing or spread toward these vital sectors like political sector, economic sector, food security, environmental sector, individual security, community security, which are really vital for ensuring individual well-being and individual security, but also community security. And I think that the concept of human security provides the vital framework for understanding these phenomena, this trend better, and maybe generate some effective responses, because we have to consider the evolution of the concept of traditional security to be more human-centered. And that was possible to happen only after the end of the Cold War and after the fall of the Berlin Wall, with all the new non-traditional military threats that started to emerge afterwards, with the creation of new states, with a lot of difficulties and challenges, human displacement, mass migration waves, and poverty, and also environmental degradation. So all these new threats that started to emerge required new responses and new measures. And then at the Toronto conference, a group of scholars from the security domain gathered to maybe discuss the changing notions of security at York University. And these debates were able then to shape later on the Copenhagen School of Security Studies, Critical Security Studies, with some pioneering scholars like Barry Boson, Ola Weaver, and Jack DeWilde. And they were able to connect human security with all these vital sectors that I already mentioned. But although they didn't mention human security as a concept, it was revolutionary how they evolved the concept of security to expand to these sectors. And Barry Boson, in his work, People, States, and Fears, asked a very fundamental question. For example, who should be secured and why not the individual? Because within the traditional concept of security, people were secured only if states were secured. But what if states are not anymore secured, and what if people are even more not secured? So I think we are revolving around that question even today. And that's why I link these phenomena, what is happening now in our region, in our small region, with lack of human security. Because with reports that I've checked so far, I think that this is really rooted in this fundamental question. And it was interesting because the architect of Human Development Reports in United Nations, Mahbub ul Hajj, started to elaborate for the first time in his report this concept in 1994, and was also able to identify the 7 essential dimensions that contribute to a sense of security and well-being, and these were economic, food, health, personal, community, environmental, and political security. And in the same vein, other scholars then started to elaborate on started to elaborate that concept, but Caroline Thomas, for example, argued that human security is rooted in global injustices related to marginalization, poverty, and continuous exploitation of resources. What we know, it is happening right now also in some parts of the Western Balkans. But the reports shows the reports that I have analyzed so far show that actually this is quite a problem for these young people and students, because we have to also consider that Western Balkans has the high migration rates in Europe relative to its population size. And according to a study by Vienna International Institute for International Economic Studies, it highlights that the majority of immigrants are skilled professionals and young people aged from 19 to 39, and in some other reports I read that they are from 23, 25 to 45 years old, so quite young. And we have to consider also the shrinking population in most of these countries, actually, because Albania has lost 37% of its population, Kosovo has lost 34% of its population, Bosnia and Herzegovina 24% of its population, North Macedonia 20%, and I think Montenegro 20% too, Serbia 9%. And according to a study by German Marshall Fund, these studies warn that the society risks losing 25 to 50% of the talent and skilled professionals in the coming decades. So this is quite concerning. And if we also consider the perspectives of these people that live in these countries. For example, in Albania, 70% of the people, 71% of youth express the desire to leave the country. And this is also in other countries, like for example, it's interesting to note what is happening in Bosnia. Annually, 50,000 to 55,000 of people, mainly skilled workers and professionals, leave the country. And the reports warn that if this trend continues, Bosnia's population could drop under 1.5 million by 2070 from around 3 million today. In Serbia also the trend is, it's really not getting better, especially in the recent years, because according to a study by the National Youth Council, 49% of the population wants to leave for better job and economic opportunities, and the average age of immigrants is 27, but also in Montenegro, 30% to 47% of the population express the desire to emigrate. But we need to carefully see analyze the key pushing factors first, because I think that this is quite rooted, as I said, in this vital sector, because people, especially young people, are not satisfied with weak economies, unemployment, lack of quality jobs, especially for this younger age. Environmental challenges we face a lot, for example, in all the region, because of uncontrolled exploitation of natural resources, industrial pollution, and controversial development projects are threatening biodiversity, public health, and really eroding hopes for better future opportunities. And pollution knows no border, but there is no enhanced cooperation in this regard, and lack of will from the governments of these countries. And we noted a lot of recent protests around the region for these controversial development projects. Social exclusion in the Balkans is a multidimensional problem with high prevalence stemming from the legacies of totalitarian regimes, weak welfare states, affecting groups such as elderly people, women, children, but also people with disabilities. We have long-standing issues with corruption and rule of law, and that has really damaged the trust and accountability and this connection that should exist between the governmental level and also the society. And issues with public order and safety, because we see limited presence of states in some gray areas, as we call them, in some rural areas, and that actually can help to foster community connections and family ties, so to rely on these connections rather than on institutions or police force, for example. But people that are out of this connection feel a bit this kind of fear and this kind of lack of safety. And when it comes to consequences, well, youth migration severely impacts the economic and innovative structure of this society. And it actually contributes to elevating the pressure on the labor market more. Too high levels of emigration can lead to skill shortages, discouraging human capital investment and hindering productivity growth. And the massive outflow of workers, especially in some special sectors like IT, education, and healthcare, can really put some burden on these sectors and maybe affect the accessibility of these basic services. And more importantly, the loss of youth energy, because youth energy is the driving force in all these countries to ensure more accountability, to ensure more transparency. So they feel that they are disconnected, they are disengaged, so that's why they are preferring this exit option. But this is really critical for the democratic future of these countries. And lack of hopes for improvements make societies more vulnerable and prone maybe to destabilization. So let's jump to recommendations. Well, the first thing is, picking up also from the discussions that we had yesterday, align education with the labor market. We need to really think about how to innovate or maybe update our curricula and study programs, because they are really old and they are not really easing this transition from study to work, and maybe offer more real because I think students also have these difficulties to do their internships before jumping to the labor market. We need to improve migration data system, create maybe a joint system or platform where we can ensure accurate, harmonized, real-time data for policy making. And this requires enhanced regional cooperation in this regard, because there is also this mismatch of data. And we need also jointly to develop tools for understanding and addressing migration, because actually there is a lot of inaction in this regard. We tend to politicize and securitize this issue during electoral periods, but that's it, and we never touch that subject again. There are some experts up and there to talk about this issue, but I think there are not real actions in this regard. We need to support immigrants' return. We need to enable circular migration with reintegration support, jobs, housing, diploma, recognition. We need to invest more wisely in remittances, because we have economies that are dependent on these remittances. We need to encourage innovation, entrepreneurship, and also to invest more on research and innovation, and maybe think how to link research with industry. That was a call also by Regional Cooperation Council since 2022, but still we haven't achieved so much in that regard. And we need to boost regional innovation through this research, and as I said, link it to industry. And EU also, the last one, has to promote the circular migration by making sure that reforms are not only on paper, but they really can improve living, work conditions, better career opportunities, and also what else? And also ensure better career opportunities, especially for women and young people. That's all for today. Thank you.
I suggest we move on. We have with us Professor Szabolcs Márka, who is, you met him yesterday. He's a professor at of physics at Columbia University, and he is also the head of the Columbia Experimental Gravity Lab. And he will address the topic of energy, security, and war and peace. So, Szabolcs, the floor is yours.
Köszönöm szépen a kitűnő bevezetőt. Ezt a figyelmeztetést elmondtam, mondjuk. Oh, sorry. My mind. Okay, so I have been warning people on multiple continents 25 years ago. They didn't listen because they claimed that this is crazy, it's prohibited by laws, it will never get done. So I heard the discussion on GMOs and genetic modification. It was amusing, yeah. Be assured, 20 years from the future, we will spread synthetic life all over the place because in war, people are desperate and they will do anything to survive. So laws will not stop them. Just remember. So here I will talk about something that was obvious for some of us quarter century ago. Today this is happening. Yeah. So my father was a vice historian, so he always told me that if you can't defend it, it's not yours. Don't get it. So just remember that every pile of gold must have a dragon on it, otherwise it would have been just carried away by random people. Yeah? So these are nerdy dragons. Yeah? So ChatGPT is a nice collaborator. So why is that important? Yeah? There are many reasons people go to war. Yeah? So two of the significant reasons prevalent to this talk is, well, there are two ways to get the gold. Mine it, that's hard, laborious, or take it from others. That's easy. Yeah? Reason for war. Yeah? Rob them. Other is two ways to win a race. Yeah? Train, run faster. It's really hard. Yeah? Or just break all the kneecaps and then you can stroll to victory because nobody can compete with you. So that's also reason for war. One is to take away the assets, land, people, whatever, of other nations. The other is they are still weak. So let's destroy them before they get strong enough to hurt. Yeah? Two major reasons. And I will make the case that there is a groundbreaking innovation called AI that will make both of these very easy. Yeah? It's a game changer. So even weapons of mass destruction are useless for war. Yeah? Everybody believes that these things are useful for war, but no, they don't fulfill the tenets of war because you get this after a war. Yeah? You pollute, you poison, you destroy the gold. That's not the aim of war. Incompatible with profit. Nuclear weapons, they do this. Useless to use them. Yeah? You don't get the gold. People are actually protecting soldiers from chemical weapons, yeah, all over the place. But soldiers are not in the biggest danger. So if you look at a big part of France, yeah, that yellow and red zone for more than 100 years is still uninhabitable, polluted. You can't do agriculture. Chemical weapons, heavy metal pollution destroyed it. We can actually detect the war preparation of the Austro-Hungarian Empire before First World War from the Tisza River, from heavy metal pollution, very heavily polluted, don't disturb the sediment. Yeah? They were mining, say, lead for bullets. Years before the war, I guess, why would you do that if you are surprised on the war? Of course, you know, we can fight plants, we can throw anthrax into a sea that dried up. You know, anthrax is prevalent for 100 years. Yeah? So all these chemical and biological weapons have a long-lasting effect considering our lifespan compared to nuclear weapons. And of course, sometimes, you know, tear gas is prohibited in war, but we are happy to use it in peace. Yeah, that's totally allowed. In a war, we can't use tear gas. In civilian life, we can. Also, traditional weapons are completely impractical. Yeah, you look at sarin nerve gas rocket. You know, it's just a dot over the scale of Washington, D.C. Anthrax is a very small effect. Nuclear weapons, you know, atomic bomb is providing some coverage. Hydrogen bomb providing a larger area of destruction, but still incompatible with the tenets of war. Yeah? And people come up with different plans. Yeah, you can spread sarin or anthrax differently, but they still leave no man's land for a long, long time, incompatible with war. And if there is even a small conflict, like an imagined conflict between two nations far away, only 100 Hiroshima-sized weapons, which is fraction of a % of our stockpiles, then we still get such a climate change. You look at the top, that's the forecast after very, very small, the smallest nuclear war people imagine, and 1816, the Tambora volcano eruption, when it snowed in New England in July. Okay, a very small nuclear conflict does that. So it is really something that produces this. It's really incompatible with the tenets of war. And if there is a bigger war, there is an interesting lesson we learn. The war itself is on the northern hemisphere, is killing a large number of people. But this number of casualties is not even comparable to the casualties, yeah, the difference between the dark and shaded lines, yeah, that's the casualties, due to the war, nuclear war, a big one. But the big thing is lack of food. This is if we would have food reserves for a long time. This is when we don't have food reserves for a long time. Nuclear war is nothing. Famine is everything. Yeah? So what is important that for every war humanity has the weapons is global. Even the dust of the Sahara reaches the Amazon. Actually, it fertilizes the Amazon. Yeah? We live on a single planet. So these things are really not used, and not because we abhor, yeah? But they are not really useful. So now I will change gear after making the case that WMD, in the traditional sense, or traditional war, when people come with millions of shells and destroy cities, I will change to people. Yeah? So our life as scientists is really changing. Yeah? Albert Szent-Györgyi made a case in 1972 that funding situation disfavors brilliant scientists. And while few scientists get to be in paradise, like in Princeton IAS or Kőszeg-Krafft, iASK, there are impediments to science, yeah, the usefulness of useless knowledge, because even the people in paradise, von Neumann and Clara Dahn, the power couple who made the hydrogen bomb and computer happened, they made a computer to forecast Soviet nuclear weapon attacks, yeah, not weather. Yeah? So even paradise is not isolated from reality. And we have science increasingly full of passion traps where we exploit brilliant minds, disgrunge them, or make them servant of money, or do not give them credit. There is a famous saying from my old friend, is that modern science, you can either get credit or do the work, not both. So that doesn't make people happy. And we have the religion of grants that gives scientists a 3 years scope, life expectancy. That's also incompatible with many brilliant minds. Yeah? So my tenet, and I think it's pretty clear, is that disgruntled, angry, disenfranchised, psycho, in need, hungry, brilliant people are the most dangerous because they are capable of doing anything. And make no mistake about it, drug cartels are run by brilliant, brilliant organizers. They are not stupid. They are brilliant, you know? And many places where bad things are happening, they are run by brilliant people. If you look at the prevalence of dyslexia in society, I'm naming few dyslexics, Richard Branson, Einstein, Bill Gates, and so on. The prevalence of dyslexic in prison is 40%. We are really pissing off intelligent people, not teaching them in schools. That's very dangerous, yeah? Because if they go sideways, that will be a problem. So, and that's where AI comes in. AI replaces the need for education. Education and capability shielded us from the disgruntled, brilliant people because they did not get an education, they did not get the capability to do real harm. They did, yeah? But AI, through its wise uses, give people fantastic ability without formal training. No, people can do anything and everything, yeah? And this will be increasingly true. And you know, I'm not even talking today about synthetic life that we spread indiscriminately on huge part of the earth. Yeah, we will. Yeah, you will see. We will spread everything. AI is a fantastic helper, and I'm super excited about it, but it is also a responsibility. When we create new things, it's a responsibility. We were irresponsible with chemical weapons. We were totally irresponsible with biological weapons. We were fantastically irresponsible with nuclear weapons. I hope with AI we will be responsible, but that's a false hope. We will not be. So, very interestingly, on my weapons of mass destruction course, I have really experienced guest speakers from fieldwork to decision makers. They always tell us, oh, you are safe. All the adversaries are stupid, uneducated. Well, with AI, that's false. They are capable. And that's a problem. So AI can empower even the untrained, the brilliant disenfranchised can do even more harm. The best thing we can do for future is pay attention to children and raise nice people, yeah? And if they have to study the wings of the butterfly, then give them the opportunity to spend their time with the wings of the butterfly, yeah? Not synthetic life. AI also promises the holy grail of war. Yeah? You remember how we started? AI promises bounty without the owner. First time in history, people can rob a full nation without touching the gold. No people, all the gold, all the art, all the buildings, all the factories. Or you can look at it, AI is a new different weapon of mass destruction for a comparable cost or cheaper than traditional weapons of mass destruction, with all the benefit of the holy grail of war. Traditional weapons of mass destruction are indiscriminate, brute, useless, destroy the bounty. AI can selectively and physically target certain individuals, certain types. Yeah? We are all different. AI can target. Yeah? Pick out who you want to keep, who you want to eliminate. Ages, looks, dresses, behaviors. Yeah? Humans. So this is very, very important to realize that we have a tool that can cut the grass by the leaf. We don't need lawnmowers anymore. You can cut the grass with robots, with nail clippers. It's possible. But there is a continuum with AI weapons of mass destruction. AI will design synthetic life within 2 weeks, for your wish. AI will launch nuclear weapons. Yeah? AI can selectively cancel the energy infrastructure. AI can surgically destroy food crops without the long-term persistent damage what chemical or biological weapons do. Yeah? Sabotaging complex system is trivial. Yeah? And the most dangerous thing, and this is my biggest fear, is people with access to the training of AI has the ability to poison the mind of entire generations, poison the mind of the young. Yeah? And that is disrupting education and the scientific process and society. So the nation that controls silicon, rare earths, and trains the globally used AI calls the shots. Local communities shall be at their mercy. Yeah? We don't have our own, we will use theirs. That's it. And we don't need this anymore. We can do it with AI. And this is the advertisement. We clean up the river from unneeded trash, 17 tons in a week sometimes from the Tisza River. And we can actually clean up a lot of the mess humanity did. And Attila will talk about how this project got to be. And here people compete to the ability to collect trash from our river. So human engineering and human good can prevail. So while it was a doom talk, I see the sunshine. We can survive this if we clean up our mess together. Thank you.
And I would like to ask László Téglási, who hails from the next city over, the city of Szombathely, and he's the managing director of Markusovszky Hospital there, and he will talk about an excellence network, as far as I understand. So the floor is yours.
Thank you very much, and I hope my presentation interested too many people here. And I say that I'm not a medical doctor, I'm a legal expert, sorry. But it means my terminology not too exactly, sorry. I start CEREN, Central European Rehabilitation Excellence Network. What does that mean? Sorry. Yes. Thanks. The mission is Markusovszky Hospital, that rehabilitation after illness and injury and surgery. Disease prevention through sports, medicine and lifestyle programs, and education and research in collaboration with the Austrian Academic Center, and integrated care across borders and disciplines. That's the mission. That's our hospital do this. And the next one, strategic pillars. 1. Specialized rehabilitation departments. 2. Location and specialization. 3. Innovation and research. 4. It's most important, target groups. 5. Revenue sources. And 6. Branding. Sorry. And next is the most, it is for important, patient, the most important for the hospital. And the human pillars is patient, nurse and physiotherapist, master social worker, and psychotherapist assistants and psychologist and speech therapist. How can I tell you? Sorry. And a social worker, ergotherapist, and folks. The next group, and rehabilitation doctor, orthoped mechanic group, and they make healthy the patient. Next one. Sports medicine and musculoskeletal rehabilitation. It means elite athlete programs, biomechanical lab, psychotherapy, hydrotherapy, and this cooperation with clubs and Olympic committees, injury prevention and performance optimization. Next one. Cardiac rehabilitation, heart attack, stent, cardiac surgery rehabilitation, and trans-border remote monitoring, and collaboration in cardiology. Congress is with Oberwart. It's a network between Markusovszky Hospital and with Oberwart. Oncological rehabilitation, and it means physical, psychological, and nutritional support. Lymphoedema therapy and fatigue management, and rehabilitation from the side effects of oncotherapy. Next one. Neurological rehabilitation. It means that programs for stroke, Parkinson's, MS, and robotic gang training, you can see on the picture, and cognitive and speech therapy. And the geriatrics and elderly care, rehabilitation for Austrian elderly patients, short intensive stays to restore mobility, and integrated geriatrics diagnostics. Health conscious education and training, leading role of hospitals, professional credibility, multidisciplinarity team, and this is my hospital. School programs, health conscious education for children and young people, exercise, nutrition, mental health, and public training, regular screenings, lifestyle workshops, community sports programs, and training for healthcare workers, emphasis on health, maintenance and prevention in everyday practice. And this is digital platforms, online courses, apps to reach the public, and partnerships, involvement of local government, schools, civil organizations, and sport clubs. This Sharvar is a flagship in wellness rehabilitation. It means this here. Hydrotherapy building on wellness traditions. Medical tourism packages, hotel level accommodation. St. Gotthard as a high-tech campus, robotic rehabilitation, neuro and cardiac center, research and innovation in cooperation with Oberwart. Oberwart and medical and academic partnerships, post-operative patient flow, student and staff exchange, and EU research projects. And innovation and research. Interreg and Horizon Euro projects, digital twin technology, AI-based personalized plans, and rehabilitation and aging research. With the target groups in rehabilitation, local and regional patients, Austrian patients based on bilateral agreements, elite athletes from Central Europe and health tourists, elderly seeking rehabilitation retreats. And revenue sources, cross-border insurance, reimbursements, private medical tourism packages, EU and innovation research funding, corporate wellness and prevention contracts, And the branding is improve life quality, restoration of health. Central European Rehabilitation Excellence Network. Thank you very much.
And now I would like to invite our next speaker, Professor István Peták. He's a physician scientist, and he is most well known for his work in precision oncology. So we might have had his talk, his contribution earlier when we were talking about precision topics, but he's the co-founder of Oncompass Medicine, yes, and also I have in my notes Genome Health, yes. Am I correct? And he has published over 200 articles, and he's a very well-known scientist in the field of oncology, and especially precision oncology. So I am looking forward to your talk. You have, again, 20 minutes, and welcome.
Okay. Thank you very much. I try to compress the journey of 30 years in these 20 minutes. Wish me good luck. But practically, yes, I'm a physician scientist, and 30 years ago, I dedicated my life to a single battle, to develop technologies that actually will enable us to find the right targeted therapy for every cancer patient based on the individual molecular profile of their cancer. So that's the great promise of precision oncology, that we really deliver the right therapy for every cancer patient by understanding the real, the basics of the biologics of cancer. And of course, we have to start reminding us why this is a very important mission. Actually, we have a 50% chance now to experience cancer in our lifetime. Sorry for this information, but that's the fact, and actually we lose 20 people on Earth every minute to this disease. So basically, cancer is the most fundamental disease, if you think about, because it really relates to the fundamental of life on Earth. Actually relates to the constant evolution of the DNA that started billions of years ago, and it's an ongoing mechanism in our body, in our DNA, and this is something our body has to control and manage. So that's why I chose this topic as a very fundamental biological question, and also a very important disease to battle. And basically the concept of precision oncology is very simple. We want to understand why a specific patient has cancer. What is the cause? What's the mechanism? Because on the surface, it's a symptom. We have a tumor, which is a descriptive word. We just see something, more cells that it's not normal in our lung and in our stomach. But actually, even if you just look at the in the microscope, the histology of the tumor, it may seem to be similar to one to the other, but if you go deeper into the molecular level, to the genetic level, we can discover and see the actual mechanism why that patient started to develop cancer. And it started in the middle of 90s when the first targeted therapies were developed, and it was really accelerated by the Human Genome Project because we needed the template, the normal template. There was 3.2 billion letters in the genome to compare it to the genome of what we find in cancer. So more than 20 years ago, after the Human Genome Project, we immediately started the Cancer Genome Project, where we systematically mapped all the genetic alterations that can cause cancer. And just as an example, and this was really a pivotal moment in my life when I experienced the power of this approach close hand when we were approached by a patient, and actually the daughter of the patient who had lung cancer with brain mets and also lung mets, and she was in a very bad condition already in an intensive care unit. And at that time we could only analyze one gene, which is called the epidermal growth factor receptor. This is the gene that translates the production of a protein that is on the surface of epithelial cell that actually receives signals from the body that sends the signal to epithelial cells to grow. So this is how the organism is regulating how many cells we should have. And when there is a mutation in this gene, it creates a faulty receptor that generates a faulty signal to the cell and will drive the growth of epithelial cells constantly without the organism really needing it. So that's the really fundamental mechanism, a subtype of cancer. And we discovered this in this lung cancer patient where we analyze this gene and find the mutation and amplification of the gene. So you can visualize it with the great technologies we discovered in the last decades with molecular diagnostic methods. So with our eyes, we can now see the genes. Those red dots actually are these EGFR genes, and we can also see that they are amplified, so that there are more than 2 that would be normal. So based on our understanding what's the function of this gene, and suspecting that it's not without reason that these cancers harbor so many copies of this gene, we thought that maybe this is the faulty gene that actually caused the cancer in this patient. So we initiated a single patient clinical trial where we obtained a specific targeted therapy that can switch off this gene. And of course you can imagine what happened after that, and that's why I'm here also, because it was an amazing experience to see how fast the patient recovered and lived for then 5 years. So then it was published in 2005, and of course we were extremely enthusiastic that soon we can find a cure for cancer for most patients. And the problem was that we knew that this specific genetic alteration only occur in 5% of lung cancer patients. So how to fight cancer with the same approach across all cancer types and all patients? So what we realized in the past 2 decades is that now we know that there are not just 1 or 2 or 3 cancer genes exist, but hundreds. Actually, the good news is that it's around 700. And so because the human genome is limited in size, and we need millions of years to develop new genes, so there are a countable number of cancer genes. So that's the good news, and humanity by 2020, we reached the point that we can identify the genetic cause of cancer in 95% of cancer patients. Now, the question is, what can we do with this information? The problem is that each cancer actually harbors a combination of 4 or 5 mutations out of millions of mutations of these 700 genes. So the challenge is how to, if we diagnose the molecular profile, tumor profile of a patient, and we see these 5 mutations that are responsible for the cancer of this patient, how we choose which therapy to choose against which genetic alteration of the 5. Because if we just choose it by randomly, of course, you can imagine that we have a very low chance to choose the right one. Actually, it shouldn't be like this mathematically, but it's interesting that actually our success rate is around 15–20%. That actually the patient would respond. And so so the way we usually conduct research in medicine is we do randomized clinical trials. So we compare the treatment options in subgroup of patient population. So now, but there are so many subgroups of patients if we consider this possible number of possible combinations of mutations, that I made the calculation that we would need 14.4 million years actually to complete this task, and then generate the scientific evidence to know which therapy to choose for which patient. So we need really an out-of-the-box solution. And this is just an example. This is one of our breast cancer patients. It's an actual patient where we did this molecular profiling. That is available also in Hungary, but in US it's actually covered by Medicare. So I'm not talking anything about the future here. I'm just talking the presence. The presence is that we can, or the physician can order a molecular profiling test. And in this case, we identified these 5 alterations. And for each of these 5 alterations, there have been drugs approved or in clinical trial for patients who share the same genetic alteration. But the problem is that this patient shares 5 of this. So this patient could be placed in 5 different groups. So the question is, which one to choose? And that's the real life problem. This is happening right now. So I give the same talk to oncologists and ask their opinion which therapy they would choose. And there is always a big fight in the audience, of course. And we see this fight. We have data about this inconsistency in opinions. So there have been studies where the same molecular profiling or test results were sent to multiple different cancer centers, to molecular tumor boards, oncoteams, and asked their opinion which therapy they would choose. And shockingly, the concordance between treatment recommendations is around 50%. So your chance that you get the same treatment recommendation from 2 different cancer centers is 50%. And of course, it makes you already wondering who is right. Which cancer center is smarter? That's what you want to know if you are a cancer patient. And we know that there are huge differences in the outcome. So therapies chosen by these molecular tumor boards, oncoteams, actually have a efficiency or success rate between 0 and 67%. So this is today. So 25 years ago, 30 years ago, when I graduated from the med school, we had the evidence-based medicine. So it means that out of that 9 or 10 therapies we had that time, we knew which one to choose based on randomized clinical trials. So everybody followed the same protocol on Earth. So all patients had the same chance to be cured. So even in Hungary, maybe you could have like a salami sandwich or, sorry, just a poor food or in the hospital, and maybe the walls were covered with mold, but you had the same therapy you would have in other hospital on Earth. So you had the same access and the same chance to be cured. Now ironically, with this great advancement of diagnostics, when we can detect multiple variables of each patient, and this great advancement of new treatment options, now we have 200 targeted therapies to choose from. This created a great opportunity, but also created a great inequity in our chance to be cured. So it's becoming more and more a matter of luck. And where you are treated. Actually, in large cancer centers in the US, patients have 9% higher chance to be cured over patients treated in community oncology centers. We don't know the same statistics in Hungary. But even between cancer centers and between doctors, there is a high variability. So I think AI is really transforming oncology in multiple ways, unprecedentedly. So just a few examples. Now AI is helping the gastroenterologists to discover very, very small polyps in the colon, amazingly, or radiologists to discover tumors in radiological pictures like mammographs, and pathologists are now aided by digital pathology and AI. So we are no longer at mercy also on the human eye. And also drug discovery is exploding. So AlphaFold can predict the 3D structure of the protein and design drugs within days or weeks. So we have an explosion of new drugs, how we can develop new drugs. But I think these technologies really just amazingly augment quantitatively our abilities in medicine. But I think there is another group of AI tools that will come and we will develop in the future that we are working on, is really tools that enable us to really deliver the ultimate dream of medicine and humanity, to really receive a personalized therapy that we are certain that most likely beneficial for us. So when we go to our doctor, he will or she will recommend to us a medicine, a drug, and he will tell us how much % of patients actually benefited from that drug. But what we are really interested in is the ability of the doctor to choose the right therapy for us. So how much % of patients he chose the right therapy to? So I mean, that's the real question. Because maybe the drug he is recommending us only works in 1% of patients, but we don't care if he has the power to predict that we are just 1%. And that I think will really transform how, if we can develop such tools, it really transform medicine completely. And this really deliver what we want from AI in this regard for good, is to really enable personalized medicine, lower differences, because in life-threatening diseases, we all humans agree, I think all of us, that there should be equity in accessing life-saving diagnostics and medicine. It's not something that is negotiable because all of us have the right for life to live. And basically, logically, this can solve, if we can develop this new generation of devices, medical devices, I call personalized treatment planning devices with computational reasoning, we can solve this inherited problem of precision medicine, that when we choose smaller and smaller subgroups of patients who are more and more similar to our patient, our precision is increasing, but our sample size is decreasing, so that our level of certainty and statistical power is decreasing. So theoretically, to the point when we no longer know what we are doing, because we don't have any experience to rely on whether what our decision is the right decision based on past experience. And so the only solution I see here is that to create machines that actually standardize how we choose therapies based on the unique combinations of biological and genetic parameters of the patient. But because this is a machine, a device, we can measure the performance with classic evidence-based methods. So simply, we will test the ability of one tool to how much % of patients the tool can select the right targeted therapy, and we can compare it to another tool that does the same. And then, if we can do this switch and start to develop personalized treatment planning devices, we can put the patient back to the center of medicine. So instead of designing clinical trials that maximize the market of a certain drug, because this is how clinical trials are designed today. actually sponsored by pharma, which is nothing wrong. It's just a scientific approach. They design, and this is getting to a crisis now of the drug crisis all over the world. That it's not sustainable. It's not a sustainable approach anymore. So, but if we can design and develop tools that will select the right therapy for the patient, then it will change the whole paradigm. And this is what we have been working on the past decades. And this is, I will not time to go through, but basically we studied the case, a unique case of 10,000 patients at our molecular tumor board. But while we did that, we tried to build an engine, a computational engine that will reproduce our chain of thoughts and logic. So to make it reproducible and also measurable. And this is it. This is what we developed. This we call digital drug assignment. Is a computational reasoning engine that combines information of all the evidences that connect one possible therapy with all the genetic alterations in the same patients. So basically it gives us the answer which therapy is linked to the most important targets that are linked to the most important genetic alterations in the patient. So it makes a calculation to maximize our chance that we choose the right therapy that has the higher chance to impact cancer growth in that patient. And we tested it already. So that was another pivotal moment in my life when we reached out to Institut Curie in Paris, where investigators led by Christophe Tourneau led the first precision oncology trial. It means that their molecular tumor board tried to select the right drug out of 11 drugs they had to their patients, and they measured their success rate. So each patient received a different therapy out of these 11 drugs chosen by this molecular tumor board. And their success rate was 50%, but the problem was that it was not better than chemotherapy. So they were very frustrated. So the concept worked, but was not better than just simply giving chemotherapy. So they sent us the data of this patient, the molecular profiles, and we predicted who would respond and who not. And we found out that patients who received the targeted therapy that was also supported by this computational model had a 4 times higher chance to respond than those where we predicted it would not work. And basically, this was really exciting because we could identify 30% of patients who actually benefited more from this individual single patient therapy than from chemotherapy. And also, we could identify patients who did not benefit, and still we would need chemotherapy. So that's really, it was cheered by Christophe Tourneau as the really the new era when we can implement the concept of precision oncology by using evidence-based. So that's I consider this, I hope this will be the birthday of evidence-based personalized medicine. So now we have evidence that our personalized approach works. And so just one example, if just one glioblastoma patient in US we received that were just 2 mutations, NF1 and PI3 kinase G, just very simple case. And current methods connect these genes with therapies one by one. So in this case, the lab result actually reported out to the physician that the NF1 gene alteration is connected to a therapy. But the problem is that the other mutation cause resistance to the same drug. Yeah, 1 minute, okay. And now this is now really exciting. This is a publication that came out in May, and where that was a 5 years long follow-up of lung cancer patients treated actually here in Hungary, in Matra Hills, in Mátraháza, and where we provided our computational report to oncologists and followed up how they used it and what was the outcome of patients when they actually chose therapies recommended by the computation in real world, in Hungary. And what we found that patients who received a targeted therapy recommended by the system actually had 5 times higher chance to survive over 5 years, 33% versus 6%. And this happened in Mátraháza, and we published in the Nature Precision Oncology in collaboration with Mayo Clinic. And so it just shows that AI has this power of being available all around the world and can create the same level of maximized chance to get the right therapy in Mátraháza or in Boston if they use the same AI tool. And it just runs on their computer. So there is no special infrastructure needed. So that's amazing about AI. And we also realized that another 30% of patients could have received high-tier computation therapy. So that shows that where we are today. So basically 50% of lung cancer patients could receive a high-tier computational recommended therapy today. And these are the recent results. I skip it. Immune therapy, very exciting question. Some patients are cured, but most of them don't respond. It's a huge burden and on the society and payers. So this is a very exciting result also that we can identify patients who really benefit from this very expensive therapy, so they should access it. So I think AI models will come to the patient bedside. It will transform how we treat patients, whole medicine. I think I agree with these authors in NIH that in the future we will no longer compare drugs to each other, but we will compare AI-based treatment assignment algorithms. This will be the new clinical trial. So IBM versus Genomate or Google AI will be the real question. And then when you go to your doctor, you will ask, which software do you recommend for my problem? And based on evidence, statistical evidence. And I think this is what we all want. And so doctors really have to adapt to this. And, but I think Eric Topos is an amazing doctor and visionary, put it very right on his book about AI medicine, how artificial intelligence can make healthcare human again. That's an exciting question. A very provocative title, and I love it. I love when I go to a doctor, and this is what I also try to do when a patient comes to me. I sit down together with the patient in front of the computer, and we ask ChatGPT together. And of course, but what ChatGPT doesn't do today yet is that I start the conversation with the question, how are you today? And the patient is surprised. But by the way, we will talk about your genes later, but AI will solve that, but how are you anyway? And that, I think this is the brilliant future we hope for and we build together, but we must come closer, scientists, doctors, and patients. Thank you so much for your attention.
Now let me call Professor Sándor Kerekes, who is a professor emeritus at Corvinus University. He's also been a regular researcher and advisor to our institute, and he's an environmental economist, and the talk is on sustainability.
Yes, certainly after the previous lecture, you know that I am afraid a little bit that maybe that I have to forget about half of my mindset, you know, that because for me the probability theory basically means mass events, you know, that, and we always wanted to learn more because we had enough big sample to make decisions from it. So it means that maybe I have a little bit advantage that I am more than 50 years in this field, you know, that, and I try to convince you that I am still enthusiastic. Meanwhile, I have to tell you that my lecture basically about why I am totally dissatisfied the result what we have achieved during these, you know, that more than 50 years. And let me show you one very nice, sorry, like I cannot find the focus. Hayek, the fatal concept, you know, that, so basically he wrote it against the communist systems, you know, that, but basically this is a lecture for all of us because we are aware that we are able to know everything and we are able to make the decisions. Everybody happy to criticize the politicians, you know that, but as a person who spent whole life in the academia, you know that I'm afraid that they are not much worse than the scientists or researchers because we are giving them food which is not eatable or not really help them to make the decisions. So you know that I basically can summarize my message with 3 slides, you know that, and I was very happy to stay at the university, which today Corvinus, but I started to work for the Karl Marx University. The name can suggest something, you know that, and later we forget about Karl Marx, but we were still economic university. Today we are the University of Corvinus University. But I had the privilege to meet with people who are very influential, you know that, and this is the 3 slides, you know that. One of them probably, Charles will recognize him, you know that this is, you know that Dennis Meadows, you know that, and you see that he's making a COVID test for me before we had a dinner together, you know that, and unfortunately he got the COVID during his stay in Hungary. It happened about 3 years ago. The other guy is David Pearce, with whom I met in 1994, and the last one is Sir Partha Dasgupta. You know that, and I will show you because I know that you cannot really read this, but this is the first and very shocking message what I got, you know that, from Dennis Meadows. In the book was published in 1972, you know that, and these are the forecasts. So I don't know why, but we are happy to forecast the future, and we think so that this is the fatal concept. We are happy to forecast, and we are able to forecast something. And certainly, if you ask him, you know that probably he would say that he was right, but we are in 2025, you know that basically everybody should collapse these years. And the good news that we still survive. We are here, you know that, and unfortunately they sent a message, you know that basically Donella sent a message to the people that don't have more than 2 kids. If you love them, you have to adapt kids. Unfortunately, she died without kids, you know that, and I am happy not to follow what they suggested me in 1972. And that's why I have 3 kids and 11 grandchildren, and I am really very happy with that. I don't want to say that it was wrong, but it is dangerous to tell the young people not to have kids, you know that, not to create a family because you don't have the future, which is dangerous. And people, you know that we are the scientists, you know that the people are able to calculate what is the carbon footprint, you know, that of a child. I could calculate certainly what the carbon footprint of the 2 dogs which replacing the 2 kids, you know that, but nobody calculating that, but they're calculating, and you see that the best, you can drive a car, you can have everything except children because they are very dangerous for the climate. And certainly, you know that we have to think whether the future is really an invention. We can change the world, you know, that as we would like to do that. We can design, you know, that like we can design the table or something, a computer. We can design the future, or it is impossible. Hayek basically, in favor of the evolutionary theory, you know, we are not able to design the future, but evolution will change it. You know that we can change it because any steps what we are making will change the future as well. You know that, but not with purpose. You know that it's happening like the evolution. It's very funny that today we have several presentations who would like to design something, you know, that and it's good. Sometimes, you know, that or bad. Sometimes I am thinking whether who is right. Basically, I am on the side of Hayek, you know, that the evolution is very important. The social evolution is very important, you know, that, and the biodiversity and the diversity of the social system is important, because if we try something, we can learn is it good or bad for us, and if we are not stupid, you know, that we will not follow the dictators because they are stupid, you know, that we will realize that they are stupid because we have seen other possibilities as well. And unfortunately, you know that if you look the 72, it was very, very basic, you know, that then the whole computer became very well known everywhere, and we used it, you know, that, and everybody wanted to have a fiber, you know, that a telephone line everywhere, you know, that we wanted to be connected, and we were afraid that we will not have enough copper, because the copper, you know, that is depleted. And interestingly, you see that today we would like to have the electric cars, and we still have the copper, but we had the forecast, you know, that any textbook what I read in my age, you know, that it forecasted that we have enough copper for the next 30 years. But I read it 50 years ago, I read it 20 years ago, I read it today. We have the copper for the next 30 years. And you remember for the Bronze Age, you know, that, and certainly we have a lot of copper because we are using, you know, that glass fibers instead of the copper, you know, that. But certainly if we will have the electric cars, we will need the copper. Maybe that we are so stupid that we will destroy the beautiful, you know, the monuments which are covered by bronze, you know, that, or who knows what shall we do. But certainly the copper is something what we need, and we have it at least for the next 30 years. But these are the forecasts, you know, that, and the forecasts are always very dangerous. And I show you one interesting forecast. When I started to teach, you know, that it was easy for me. One of the poorest countries in the world is Bangladesh, you know, that, and basically overpopulation. These are the buzzwords. And what they did, you know, in Bangladesh, they had the fertility rate in 1960, which was 6.7. Today they have 1.9, you know, that, and how they achieved it. You see the girls are running on the bicycle to the high school, okay? It was not like in China. It's a soft methodology, you know, that you give a bicycle to the girl, he can go to the high school, he will study instead of giving birth, you know, that in 14, 12 years, girl would start to give birth to the kids, and they will have the fertility rate which is above 6. They are below 2 already. And this is happening not only there. But this looks a success story, you know, that, and at least for me. And David Beers, you know, that I was very lucky to meet with him, because I was, how can I say that? Everybody was speaking about the chaos of the future, you know, that the impossibility. And David came to my room, you know, that, and we had a couple of bottles of wine, you know, that, and he made a flip chart for me. And he summarized how to change the world, how to change the economy. The first graph is about the circular economy. Today, everybody is speaking about that, you know that, but it happened, you know, that in 94, and he started with bolding, going back to 67, you know, that, which means that the circular economy is old stuff. It seems to me that it needs about 60 years, you know, that something which is in the mind of somebody in the real world start to work, because the politicians and the economists and other guys, the rich people, understand that this would be good for us. The second is the decoupling, that we have to separate the economic growth from the pollution, and it's possible. Yes, there's a lot of people against the economic growth, but can you imagine that how to survive with more than 8 billion people if the economy would not grow and would be not able to feed them with the necessary goods and services? So decoupling means, yes, we have to put the split. The split is a regulation. The split is a protest against, that the things what are wrong, against the dictators, against the idiotism, against the very rich greediness, and so on and so forth, that. But it's possible to separate the economic growth from the pollution. But the third one is the most interesting, that this is to change the stock economy for flow economy. So instead of using the stocks, we have to use the services. I don't need a car, I need the mobility. Can you imagine, we are using the car for about 30 minutes per day. If you would not use a personal car, it's good when you design the treatment personally, but we don't need to use the car personally. Because we are using the car, that, and we are using a lot of raw materials, and it will obsolete, that, and so on and so forth. So this is very difficult because we are very much comfortable that we are rich. I can show I am driving a good car. I have a good car. It's a prestige, that. I am not sharing anything. I am not washing my clothes together with somebody's. That it's my personal life. That I would like to separate from everything. Certainly, it was told by him. It is possible. This is an economy. That it's not against the economic growth. It's not against the well-being. This is against the stupidity, something wrong. We cannot have a linear economy. We cannot transfer the raw materials into waste. We cannot have an economy where using more and more energy, and we are not producing more and more wealth. We cannot own everything. So we have to think how to create a kind of sharing economy. It doesn't mean socialism. It means, that a normal. We have a car, we have the mobility even by personal cars, but we are using not one car alone, we are using the car together, that not half an hour a day, maybe the car will run 12, 13, 14 hours per day, and it would be much better. And when I'm speaking about bend the trend, that unfortunately, as an economist, I see that we are studying statistics, that, and we are calculating the future from the past. So if the water consumption used to grow, then the water consumption should grow. If the energy consumption used to grow, it should grow in the future. Everything should grow. Sometimes I'm calculating, that if the people who are working in the field of tourism, that then they are calculating that how many times a year I will walk around or fly around the world, but I have no time for it, that how many nights I will spend in a hotel, that, but unfortunately I have no time to spend so much time in the hotels. But they are calculating the future of the tourism industry. And they are calculating everything, that we have to change the trend, that certainly these are the same messages what were told basically by David Pearce, that in 1994, but this publication is quite new. And certainly we are speaking about the absolute decoupling and we are speaking about the relative decoupling. The relative is easy, the absolute is more difficult, but certainly we need both of them. And unfortunately, that the economy is working, but when I'm speaking about the regulation, we are giving bad messages. So basically, the labor productivity is growing because the labor is going on strike. They would like to have higher salary. So all the managers are happy to fire people from the corporations, even replace them with robots, because the robot is not making strike and the robots are cheaper because it's made from material. But unfortunately, we have a social problem here, that then if the labor is not employed, the labor is dangerous. So if we want to have a society which is stable, and working properly, then we need to employ everybody. And better to learn this, that so when we are speaking about how many people should be replaced by robots, that we have to think about that what shall we do with the guys who are doing nothing, that and they cannot satisfy their needs, that and they are making extreme idiotism, that like terrorism and so on and so forth. And here is the third one, and certainly I got the message already, that, and I will finish. But what is interesting here, that he is writing that we have been living at both the best and the worst of times. So the more than 8 billion people having a material life standard as an average, this is the stupid statistics, the average life standard of the 8 billion people is higher than ever in the history of the humans. But in worse time, because certainly the biodiversity is endangered, we try to reduce the biodiversity because we are competing with the animals. We don't want them to eat what we would like to eat, so instead of let them survive, that we try to have only chickens, that we don't like the animals which are living in the wide nature because it's economically not feasible. Today we would like to eat a chicken which is living for 6 weeks, that, and it is more than 1.5 kilograms. I remember in my childhood, that the chicken used to be after 6 months about the same, with the same body. I stop here because I am very nice when I show you one, but many other I would, but I want to. This is what I want to show you guys. I want you to learn something. Thank you.
Thank you, Sándor. It's so generous of you. And we have arrived to the very last talk of this morning. And before the talk, I just want to make a note that we won't have the Q&A session after the talk, but feel free to talk over lunch and to ask your questions, comments, and then we have plenty of time later on. So I would like now to call Feyrouz, Ahlam, Saidi. I'm butchering this, I'm sorry. She is a recent PhD from the University of Debrecen. She's a regional geographer, social geographer and regional development expert. And she works on small and mid-sized cities and their development potentials. So the floor is yours. Thank you.
Hello everyone, my name is Feyrouz Ahlam Saidi. Today I'm so excited to be here, to be presented in this very nice presentation. I was so excited, and I hope it is not the first. I mean, the last one, the last presentation will be here. So today I'm gonna present just a few question and presentation about the future risks of small and medium-sized towns in this case. So we all know that that large cities are having more dense population and having more mix of activities compared to the rural areas. Rural areas are usually having fewer population and then more related to the agriculture. But we don't care really about the small and medium-sized town, which is interconnected areas between these two rural and urban areas or big cities. And then also within this kind of economies, because it's having more services and administration and also kind of economies, but in this time it's not mixed as large cities and big cities, but this kind is about having some trades, administration, and also some, for example, light manufacturing in this sense. But also it having very strong social ties compared to the big cities, and also that could be also be a part of the for the reducing spatial inequalities between these two different areas that we have in rural and big cities. And for this in this problem here, we need to focus more on the small and medium-sized cities that it is could be in the future for the more balancing of our national system and also diversifying the economy and fostering also sustainable growth. For this point, actually, my presentation here is aimed to or I summarize it in just 8 points in here. What are the risks of small and medium size and how we can deal with it. So we know that we have like environmental risks, social inequalities, in-planned urbanization, out-migration, infrastructure and services gaps, global governance, and also we have economic fragility and globalization pressure. But those points actually doesn't work like from separate to each other, but instead of that, they are all connected. For example, for the out-migration, when the people lost their, there is loss of population from small cities to the global, to the big cities in order to having like more opportunities. So in this case, it will lead to economic fragility in this case, and because of also globalization pressure, this aggravates the problem. And for example, also for the social inequalities, when have a more marginalization of the of this kind of towns compared to the big cities. So in this case, it is more related to the governance, which is having like very weak governance. In order to focus more in those towns, they focus on large cities. And for example, also in planned urbanization, it could be lead to environmental risks, and also for infrastructure gaps also could lead to the both environmental and economic fragility. So all of them are mixed together and are not separate and are interconnected to each other. So let's try first within this first point, which is about the environmental risks in this case. And in this problem, I will go to Germany. Here we have in this case of the state of Baden-Württemberg, which is located in the southern western part of Germany, which having more characteristic of environment, which is more having this, there is an increase in the hot days and floods, and this is kind of a problem risk to the climate change. So in this case, actually because of its geographical location, so this study focused more on how we deal with this climate change. And for this map here that shows that the state population that are more located in 80% of this state population are about the small and medium-sized town location. But instead of that, there is the color here of the green light color and also the gray one, which represented that there is not interconnected between the global and how we deal within the political dealing with how we deal with this climate change problem. But for the state, for the big cities that contain only 20% of this state population that having more adaptation within this developed policy of dealing with this kind of climate change. So in this study, here we summarize it as the study emphasized that there is a need for a structural network that can support small and medium-sized towns by promoting knowledge exchange, cooperation and resource sharing to enhance their capacity and to adapt with climate change impacts. Then we have the second point, which is about the social inequality in this case. Of course, here we don't need to explain how the urban shrinking is happening and there's causes and consequences, but just from BRAVE that there is a demographic change and there is suburbanization, political transformation, and also economic restructuring, which is lead for a very serious problem in this case, and all are mixed together. For example, for dealing with the high number of vacancies, or just there is also mass of immigration, and then also to it will also lead to increase the inner crimes and so on. So for this case, I'm gonna go with Hungary actually to be more precise. This is a research of Dr. Horsky and Dr. Gabor Perizzi and Erno Molnar, when they focus here on how to just focus on what is the growth of small and medium-sized towns. But in this case, precisely is about having this kind of 6 categories that about the small towns in this case. So here we have in that this map shows that there is an increase in the urban, there is an increase in population in the small towns in central Hungary near to Pest country, but also there is a kind of decrease in other places like the Great Plain and also the southern part of Transdanubia. But there is also stability, kind of stability in small population growth in northern part of Hungary and also near Debrecen, Szeged and Pest. So in this case also the authors mentioned that there is the tourism can boost the population activity of small towns, but also industry can do so, but if their success is dependent on their location exactly. Then we have another problem, another example of, or another case study of Spain, when we have the shrinking of medium-sized cities, and we can say that there is a spread of shrinking of these medium-sized cities in all Spain and more in the northern and interior part of Spain. And this is because, again, to the shrinking because of the demographic and socio-economic factors in this case, and we can say that there is an emphasis on the need for the better research and target politic to help this medium-sized towns policy. And again, we go to the Algeria here, just to know that there is, for Algeria, there is no problem for, we don't have this kind of shrinking of towns, but instead of that, when we have this kind of three census, we analyze this kind of three census, and we found there is an increase in the number of population and also urban settlement in Algeria during this 20 years compared to the large cities. Of course, large cities having more population because there is having like more than 100,000 inhabitants. But compared to the small and medium-sized town, there is also a big increase of it. But here also we have a special distribution of urban settlement in Algeria during the last census. And when I calculated and mapped this statistic here, we can find there is also there is a big big large cities are located more in the northern part of the country compared to the southern because of the climate, social and also economic factors. But here also for the second map, I summarize it in the more categories, which is smaller and smallest urban settlement, which is the smaller towns in here, and we can there is a huge number of small towns that we have to take care of it. And then we have in-planned urbanization. For this case, I will go to Ethiopia, when here the authors try to have like 6 towns case study, and in this case they emphasize that there is a large urban growth in the number of the landscape there is an increase in the vegetation as well. So here, that in-planned urban growth in small towns having this kind of environment degradation and challenges in the sustainable urban management. And here there is a real problem. And also for the out-migration, we can say back again to Hungary with another study of Dr. Gábor Pirizi, when he mentioned that there is an out-migration, like increase in out-migration between the population aged between 20 to 29 years old, which is very serious and a complex out-migration, which is, he mentioned that there is age and skill selective population in the out-migration of Hungary. And then for the infrastructure and services gaps plus governance, here I mentioned it in 2 other case studies of one of Wales and the other one is in Czech Republic, but having the same almost problem. But there is suffering from the weak governance capacity, because even for the first case study, even they want to diversify the economy, but they couldn't because there is a big gap in the infrastructure, and it mixed also to lead them to the stuck in the cycle of decline. And the other case study as well, within having this kind of the impact of deindustrialization, even if for long term actually, and also because of the weak governance, they cannot support more infrastructure, investment, because they have also gap in infrastructure and so on. So for both studies, experienced a decline in the or there is stuck within this kind of circle of decline caused by weak governance, poor infrastructure, and limited services, which need to really take care of this problem. And then we going back to economic fragility when we have in two case studies, almost the same problem. The first one is having that in South Africa case study. Here, the small town, it's about 15,000 inhabitants, and they suffer for just for their economy that focus only on one sector, which is tourism. And after the COVID-19, this because of the close of everything, so this is the town having very serious problem in its economy. And the same way within this small town in Cyprus, which is also having serious economic fragility, because not because of the COVID, but this time within the problem of 2008 crisis. Here, there is just a conclusion, but there is here a need for diversification of the economy in small and medium-sized town. And here, back to Algeria, again, here I just want to mention that here we having this map of location quotient of the medium-sized cities and smaller, and also smaller or smallest urban settlement. And here we can say that, okay, there is an increase, in this part of the northern of the country compared to the southern, also because of the same reasons. And here there is, the small and medium-sized town in Algeria play a critical role in regional and economic development, and also it is good to the, it is very, very important to compare to the large cities. And here, for the globalization pressure, also another example of a small town of Algeria, which is actually a small town which is presented in the highland east part of the country, when we have 17 interviews. And according to this, because this small town had its a cement factory recently in 2019, and here we're having this positive and negative effect as well. So for the economic aspect, here we're having there is a meet of local demand in cement. Of course, this also this factor is developed infrastructure because of the role of the state in here that encourage this cement factory, and also having some employment and jobs, direct and indirect. But on the other hand, for the social aspect as well, it means that there is investors in work training, for example, because of this factory is having from infrastructure from France, there is a need for training people to how to deal with this technology. And for the environment aspect as well, it is increase in primary resources, but here we can say that there is a negative effect even within the three concept or the aspect. So for the economic aspect, there is a decline in real estate, of course, near to the plant, and also it could be lead to the social displacement and cultural erosion. And also, even if according to the interviews, they said there is no effect on the environment because it is having a good and modern technology. But for example, if there is no change of the filter, it will be a problematic in the pollution. So this study summarized that there is a reflect on how the global market demand and international standards impact the local industries and communities. And also it is a very, that the globalization having most, positive and negative effect in this sense. And even if summarized all the studies, the lesson of this small, all the studies in the other slide, but here I want to make it more general, and how can we deal within this problem to more improve the functionality of small and medium-sized town. And for example, here we need development, local and regional political framework, encouraging territorial cooperation and multi-level governance, and also building local capacity, and also promoting economic diversification in this case, and also integrating the spatial planning and deal within this the development of infrastructure and enhancing accessibility, and also fostering innovation and internship, and also developing community and cultural assets. And that's all. Here they have some references. Some of them are my contribution, others are very good references based on this this presentation. And thank you so much for your attention.